Everyone, in this video, I'm going to give you an overview of the Chapter 5 assessment project that you're going to be doing on day 2 and day 3. If we take a look here at the directions, you are in the day 2 folder already, and I'm just going to kind of peek in it really quick on this side view. You are watching this video here, but if you go into the Chapter 5 project folder, you're going to find all the good stuff you're going to need. This document we're going to pull up in just a moment, and it's the guidelines for the project. These next 3 things, I have a video that is going to support you and show you how you can find an electronic ruler and an electronic protractor if you don't have a ruler and protractor at home. Most of you might have a ruler, but probably not a protractor. So this is a really good tool. It's a second video I would recommend that you watch, and I show you how you can add on these 2 extensions to your Google Chrome feature so you can use them. I also will have a video of me walking through a sample project that I will do partially to give you an idea of how you can get started. Then on day 3 is when the project deadline comes in. It's the deadline is at 3 o'clock on day 3, and what you're going to do is you would just come on into here, and you're going to upload your project information here. What you're ultimately going to upload is a picture of your project in terms of a polygon shape you're going to end up drawing and all of the supporting math with it. So let's actually go on in, and I'm going to click on into the Chapter 5 project folder, and let's pull up the guidelines, and then we talk about what is expected of you for this project. Now, the main goal is you're going to draw a 6-sided polygon, which is called a hexagon, and you're going to compute the area of that hexagon using just triangles and the math that we learned in Chapter 5. So to do that, here, let me just give you an example of what you might draw. This is my drawing right here. This is a hexagon, and you're going to see the 6 sides and 6 angles. So what we're ultimately going to do is you need to get your own ruler and protractor, and you're going to measure all of the side lengths and all of the 6 interior angles and label it. That's really step 1. Step 2, what you're going to do is you're going to sector off this inside into triangles. Now, this is not going to be the straightest line because I'm doing it on my computer. There's 1 triangle, here's a second, and when I do that, I have 4. So there's 4 triangles. You're going to have to use SOHCAHTOA, law of sines and law of cosines, and our triangle area formula to compute the area of all 4 of these triangles and add it up. And that's really it. So let me kind of walk through the guidelines for it. How do you do this? First thing you're going to want to do is, if you do this on paper, is just go ahead and get some no-line paper, like typing paper. If all you have is school book, notebook paper, that's fine. It's not the best, but it's fine. Some of you really like to use your computers. You can draw a hexagon using a drawing tool on your computer. That's fine. What do you draw? 6 straight lines at a minimum, and it's enclosed. That's going to get you the polygon you need. Now, there's no reason anyone should have the exact same polygon, especially since you have to measure it in centimeters and you're going to use your protractor to get the angles. Everyone's going to have something slightly different. Be creative on what you need this to look like. It doesn't have to look as standard and kind of boring as mine. It can be something that's concave, maybe looks like a star, or something that looks kind of just crazy, but it is a 6-sided polygon shape. Now, that first step, after you draw it, you're going to go and you're going to measure the exterior lengths. You need to be to the 10th of a centimeter. Again, I already pointed out that I have this extension. There's a link in the Chapter 5 folder for this Edge web ruler. Please watch the video and download that if you need a ruler so you can get all the measurements done. To get the 6 interior angles, you're going to need a protractor. You need to do all of the angles, and this protractor tool, again, it's in the Chapter 5 folder, is a really great tool. The video will show you how to use that. Measure that to the whole integer. After you've sectioned off how you want to get your triangles in here, the key here, by the way, they can't be overlapping triangles. So when I go back here, what I mean by that is if I were to draw another line like from here to here, I definitely broke the rules. Right here, this cannot overlap. So it looks like there's 6 triangles here that can't work. That line is not acceptable. So you actually would have to get rid of that overlapping feature there. So after you have that, then we are going to go on in, and you need to use SOHCAHTOA, Pythagorean's theorem, law of sines, law of cosines, your knowledge of angles, and you need to measure in every single line length. So there's 3 line lengths you have to get, and every angle has to be mathematically computed. When I look at this right now as the drawing, if I kind of put this feature back in here a little bit, there's only two angles that I can technically use. On here, this angle right here, I can use, it's already done, and this angle right here, I already measured. All these other angles have been split into smaller angles, right? So they're adjacent. So you have to mathematically compute that angle, this one, this guy, this one, here and here. All those green dots are angles you're going to have to do mathematically. So if you look at that, you're going to see 10 different angles and 3 different line segments. That's math you're going to have to do. So that's 13 steps of math. You're going to have to find that all using your techniques. The last thing you're going to then do is you're going to come in and find the area of these 4 triangles added together, and you've got it. So if we take a look at this, it says here on this next step, you're going to compute the area of each triangle. Once you have all the side lengths and angles, that's easy to do, you guys. After that, ensure that your work is easy for me to follow. When you're coming back here and you're finding maybe this side length, can I tell where the math is for that? How about when you find this angle? Can I tell where the math is for that? So just organize it nicely. Then when you're done, you're going to go back to into day 3 and upload the photo of your image along with all your supporting math. How is it graded? I'm going to correct it this way. These 5 categories, each are worth 2 points, so 10 points in total. First thing I'm looking at, you have to use law of sines and law of cosines each at least one time. That's not going to be hard to do at all. You can use SOHCAHTOA or Pythagorean theorem, but it's not required. If you don't have any right angles in your triangles, you can't use those anyway. Step 2, you can use the right triangle area formula of 1/2 base times height one time. That's it. I need you to use for the other 3 at a minimum the new area formula 1/2 AB sine of C. Number 3, your drawing or the image that you've done has to have at least 6 sides. I wouldn't do more than 6 sides. It's just a lot more work. 6 is sufficient. You can do more if you want to, though. Your shape cannot be a regular hexagon, which is all side lengths and all angles congruent. So that's the only shape I don't want to have seen out there. Anything else is fair game. The sides and the angles must be accurately measured. Are you using your ruler? Are you using the protractor? So step 3 is really actually not going to be a hard one to get the points on. Step 4, all the supporting math must be included for every single line and every single angle. Again, there's 3 interior lines and there's 10 new angles here. You're going to have to do all the math for that, in addition to finding all the areas of the 4 triangles. But that's not hard once you have all of the side lengths and angles done. Your work then for step 5 needs to be submitted and organized. So is it easy for me to follow? If it's not, you won't get all 2 points for that. If it is, you got it. The deadline again is day 3 at 3 p.m. Anything submitted after that can only earn up to 60 points. Now, I want to show you here, if I go back and we go into the day 3 folder, when you do upload this information into this assignment here, prior to day 3 in the deadline though, I'm going to hold a Zoom conference session. On your day 3, you're going to be able to go into this assignment here, and I will have your Zoom conference information. It'll have the ID that you can use or the link. The sessions are going to start right here as it's shown. So for 4th hour, you are Friday, April 3rd at 10:30. 3rd and 7th hour, you're going to be on Monday as your day 3, 10:30 for 3rd hour and 1:45 for 7th hour. I'll have this Zoom session open for 10 to 15 minutes if you want to join. It's not required, but if you want to come in and ask questions, we're ready to go. This, by the way, is the Zoom session information right now for 4th hour. 3rd and 7th hour, I will get you your information. If you look at this, it says for 4th hour. If you don't want to join the Zoom session, but you have questions, please email me. This is my email right here. Please be very cautious though on this email. I am Landon N. Landon D is not me, and I will not get that information. So hopefully this makes sense for what's expected of you of the project. If you want some insight on maybe how to start, I am going to go again back into the chapter project, and you're going to find a 3rd video By the way, the second video, right, is if you want to use those online tools, please watch that and I'll show you how to get them. The third video, though, will just be me partially walking through an example of how I would start and actually compute the area of this particular shape using the project guidelines. Please email me if you have any questions. Good luck, and I hope you use a lot of your Chapter 5 skills on this project.